Hello! In this video I'm going to be doing an example of a stoichiometry problem, a basic problem. It's where I have moles of a substance and I want to convert to moles of another substance. First of all, what is stoichiometry? Stoichiometry comes from two Greek words. Metri stands for to measure. Stoichion stands for elements. Basically we're measuring elements or ratios of elements, ratios of reactants to products or reactants to reactants. And we follow the law of conservation of mass, meaning matter cannot be created nor destroyed. Alright, so in this example problem, we have how many moles of hydrogen are needed to completely react with 2 moles of nitrogen. And right up here, I've got my little stoichiometry buddy sheet right here. It's 5 steps of stoichiometry. If you follow those 5 steps, they will lead you to the correct answer every single time. So, step 1 is write and balance the equation. It looks like this equation is written and it's already balanced. So that makes that a lot easier. And on your test, it is already going to be balanced for you. So the focus is really just on the stoichiometry, the mole ratio part. Number 2, write down the given information. So the given information comes from our question right here, and it's usually just the only number that they give you, that's your given. When it gets a little bit more difficult with limiting reactants, you'll have 2 givens, but we'll get there when we get there. Here, we just have react with 2 moles of nitrogen. So I'm going to write down 2 moles of nitrogen, and I remember nitrogen is one of my 7 diatomic elements that are found as N2 instead of just N. Alright, that's step 2. Next, I've got step 3, which is convert given to moles. In this case, I am already in moles, so I can check that step 3 off. Just skip it, because it's already in moles. Go on to step 4. Mole-mole ratio to convert between different substances. So, I'm starting with 2 moles of N2, and I want to convert it to moles of hydrogen. I'm going to multiply it by mole-mole ratio. I put what I want to get to on top, which is H2, and what I'm getting rid of on the bottom, which is N2. And normally, when we were just converting like grams to moles or moles to molecules, we would just have 1 mole for every 6.02 times 10 to the 23rd molecules, or 1 mole for every molar mass of a substance. In this case, we could potentially have more than 1 mole. That's the only time you could have more than 1 mole, is if you have a mole over mole ratio. Where do I get my numbers? I'm going to get them from my coefficients found in my balanced equation. For H2, we've got a 3 in front of that, so I have 3 moles of H2. For N2, there's no coefficient, so it's assumed that you just have 1. So it's a 3 to 1 mole ratio. My moles of N2 cancel out, and I'm left with 2 times 3, which is 6 moles of H2. Then I'm left with my last and final step, convert moles of new substance into requested units, or ending units. Looking here, it says how many moles of hydrogen? I've got 6 moles of hydrogen. So it looks like I'm done. If it asked me how many grams of hydrogen, then I would have to take this 6 moles and multiply it by the molar mass of hydrogen. But it asks for moles, so I am done. And sig figs, 2 moles, or we got one significant figure. And that is how you do a mole-mole stoichiometry problem.